No.
Lesson number 21 is just single step equations. I will not spend hardly any time because this should be pretty easy. It's just this: x plus 6 equals 12, x minus 3 equals 15, x over 6 equals 20, and 6x equals 18. They are equations that you simply solve with just doing one step. If it's an addition equation, you subtract. X equals 6. If it's a subtraction equation, you add. Do the opposite. You do both sides. If it's a division one, you multiply. You get 120. And if it's a division multiplication one, you divide. X equals 3. Enough of that. This is not. I mean, this would be very, very interesting. What does 21 ask? 21, the statistics, we don't have to, you already know what a stem and leaf plot is, right?
No.
Oh, no, you don't. Let's do that.
I do not. You know what a box and looks.
I know. Or you know line plots, stem and leaf. Let's do it. That probably comes up on the next section.
It does. And I just guessed. Yeah, I don't.
So, I'm sure that I Excel and I have to look up how to do it.
Is that cheating, I hear?
Wait a minute. It's looking up how it is and not the answer.
You probably look up the answer as well, though.
How do you look up the answer to a leaf plot?
How do you look up the answer to a question?
How about we both be quiet before you get in trouble? Alright, stem and leaf plots are really, really, really simple. They're based on this. You have the stem and you have the leaf. I think it's some sort of a connection to a plant or whatever it is. But basically it looks like this. The leaf is always the last digit of whatever number you're talking about. You know, 5, 6, 9, 2, 4, whatever. The stem is whatever digits come in front of those numbers. And it's nothing more than a glorified way to organize your numbers. Alright? You would start with, the first thing you find is your smallest stem. Well, the smallest stem is 1. Okay? You've got two, both of these are 1s. So you put the 1 here, the leaf goes here, and the other leaf goes there. This stands for 16, this stands for 19. And then we have another 9.
What about the 17?
Oh, is there 17?
Yeah.
Oh, then there's a 7. It gets slided there. So yeah. So you've got 16, 17, 19, 19. I really should look a little closer. And then you go into the 20s, which would be your stem of 2, 26, and 27. The only 2, 6, and 7. And then your 30s, which would be 35 and 38. And then you'd have your, do I have 40s?
Yeah.
Oh, did I miss 14? Why did you tell me there's a 14 here?
There's a 14.
And then your 40s was 42. Your 50s was 53. No 60s, we have a 70 there. 70 whatever, too. If it would be, you know, if it was 108, then your stem is a 10. You would put a 10 there. 10, 8. The leaf always is a single digit. Your stem can be any number of digits based on how many numbers come, what digits come in front of that. But it's just a quick way to organize it so that you can see. You know, if you were looking for the median or the middle number, how could you quickly find that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 numbers there. The middle of 13 is the 7th number. 1, 2, 3, 4, 5, 6, 7. Your median would be 27. You know your range, you got 14, you have 108. Your mode would be, what's my mode?
29, 27, 19.
19, because there's 2 19s there.
What is it, 19?
Yeah, what?
Parker, are you confused?
Circle graphs, pie graphs, enough of that. Two-step equations. I don't know if we really need to do those either, but let's do just a couple. Lesson 23 is two-step equations.
What lesson is this stem and leaf plots?
Okay. Lesson 22. And these again, you should have been doing since forever, but let's do the hardest one. 1/8 m plus 3/4 equals 7/12. I always say don't let fractions confuse you. Think about what you do. If they weren't fractions, what should be the first thing you do in multiple step equations? It's like backwards. Do you remember back in 7th grade when they said solve by inspection, where you would go 2x plus 4 equals 8? And they'd say, just look at that, tell me the answer. And what would you do? You'd do this, you'd go, okay, what number when you add 4 to it gives you 8? 4, so this has to be 4, so 2 times what number is 4? 2, so x is 2. Notice what you did there. You actually went backwards distributive property. In other words, you did the addition stuff actually first. You're basically trying to undo the problem. So you go backwards distributive property. And then you did the multiplication division stuff first. So the same thing is true for these. You want to get rid of this first. And how do I get rid of a positive 3/4? I subtract 3/4, which is what? 9/12? Is that right?
Yeah.
And if I do subtract 9/12 from that, I get negative 2/12, which is fine. And now I have this 1/8m equals that. And how do you get rid of the fraction in front? You flip and multiply by 8/1. It's really divisions, like when you divide, you flip and multiply. So this is 8/1. You know, you can cross cancel however you want. 2, 6, 3, 4, negative 4/3. You can leave them proper fractions, by the way, as long as they're reduced. How about that? Let's keep moving on. Now, the one thing you're going to learn today is this. Moving on, lesson 24 is about decimal equations. I am going to rock your world, children. Rock. 0.2m. Sorry. I really should do it. Let me do a hard one. I want to give you the hardest one humanly possible. Oh yeah, here's one. Write down this problem here. 0. I can't read it. 0.05 equals 0.5 minus 0.15x. Now, the issue with this is most people just kind of get goofed up with the whole decimal part of it because, you know, you got to divide by decimal, multiply by decimal. But there's a helpful little thing that you can do to this that gets rid of all the decimals. By 100. As long as you multiply everything by a number, you can multiply everything by a number. Okay, but it has to be every term. To get rid of the decimal in all of these, I'd have to multiply or move the decimal 2 places, which is multiplying by 100. If you multiply by 100, you would get 5 equals, you just have to be careful that you are moving the decimal 2 places, 50 minus 15x. Does this not look a lot nicer to solve than that did? And you just subtract your 50. Subtract your 50, you get negative 45, and that equals negative 15x. Divide by negative 15, divide by negative 15, and x then equals 3. You still can work it the hard way and use all the decimals and stuff, but this way I think you'll find yourself in a little bit better place. If I go back to this one, the same rule applies to this. If I got rid of the fractions, it would be a lot easier, would it not? Just say yes.
Yes.
So the question I would have for you is this. What could I multiply everything by to get rid of every fraction there? Which would be, by the way, the least common multiple of the bottoms. Or if you were adding those fractions together, what would be your smallest number that they all go into?
24.
24. So if I multiplied all of these by 24, watch and see what happens. Through only the magic of mathematics. 8 crosses off with the 24, leaving you with 3m, plus 4 crosses off with the 24, give you 6 times 3, which is 18. And 12 crosses with the 24 2 times, which gives you 14. Same equation. Will I get the same answer? Let's see. Subtract 18, subtract 18, I get -4. If 3m equals -4. Look at, is that not a little nicer? How many people like that? Everybody, good. Your assignment. Whew, lesson 24, how about that? For breakneck speed. Nobody really wants to break the neck though. Wow. What, ladies and gentlemen, should we do? I am